Welcome everyone to this lecture. So, from the two previous lectures we were seeing some basic introduction about Ethereum and how we can use the Ethereum clients to interact with the Ethereum network. In this particular lecture we will be moving one step forward. So, instead of using the Ethereum client directly for communicating with the Ethereum network, we will see how we can use the Ethereum SDK called web3.js to build Ethereum applications which are called distributed applications or dApps. So, we will be using web3.js to programmatically access Ethereum network, which can later be used to build application interfaces for our Ethereum application use cases. So, the keywords for this lecture are web3.js and decentralized or distributed applications called dApps. So, what are dApps in context of Ethereum particularly? So, dApps in general are decentralized applications. So, the applications which are actually not running in any centralized server or any central with any central authority. Instead, they are being run in a completely decentralized setting by multiple independent participants. So, in context of Ethereum, an application which is built for the Ethereum decentralized network is a dApp. So, these particular applications are basically composed of two main components. One is the smart contract and the second one is the user interface for executing transactions via those smart contracts. So, if you notice this diagram, then in the Ethereum network, the participants of the Ethereum network which are called nodes, the smart contracts are actually deployed. So, the code of the smart contracts are being executed independently by the participants of this Ethereum network, and then the output of a smart contract execution is actually determined by the consensus protocol which the Ethereum nodes are running. And this smart contract is used from a dApp UI. So, to execute a smart contract, to query it or do some transactions over this smart contract, there has to be a UI through which the user would be able to interact with this contract. So, this dApp UI is actually used for interfacing. Now, in the context of this network, Ethereum network and its different components, where does this dApp UI and the smart contracts lie? So, if we consider this network like this, a peer-to-peer network, mesh kind of a network of different independent Ethereum nodes which form the network, then this Go Ethereum client or the Ethereum node is communicating with the individual participants in this network. But the dApp UI would be required for the end users to access the network, because as we saw, we can use some post request through RPC over HTTP to interact with Go Ethereum client and thus the Ethereum network. But for an application you need one interface which the users can use. So, this dApp UI sits between the Ethereum node and the user. So, the Ethereum node is basically Go Ethereum client, or there are other examples also like Infura, etc. Now, to interface with the Go Ethereum client and to build these dApps, we would be using a particular library, or we can consider is an software development kit SDK. So, which is called web3.js. So, this is basically the Ethereum JavaScript API, and this Ethereum JavaScript API is a collection of libraries which we can use to streamline the interaction or interfacing with the Go Ethereum client. So, whatever we were doing in the previous steps in the last lectures through post requests would be much more easier with this web3.js. So, we would be using web3.js to connect to Go Ethereum client get, and then this Go Ethereum client is of course connected to the Ethereum network, be it mainnet or testnet or whatever network, and this web3.js, using this web3.js the dApp UI can be built. which would be ultimately used by the end user. Okay. Now, how does this web3.js connect to this Go Ethereum client? The ways are the same through which we were accessing Geth. The options are HTTP and WebSocket. So, this is RPC over HTTP or RPC over WebSocket or IPC. So, these are the three options using which this web3.js application can interact with Geth. So, to get started with web3.js, we would need to first install it. So, this particular SDK or library is a Node.js library. So, to run applications that use web3.js, you need to have Node.js installed as well as npm, which is the package manager for Node.js, using which we would install web3.js package. So, the first step is installing Node.js, that we can do from by downloading Node.js package from the website and then extracting it and then properly configuring the path to its executables. And then finally, after Node is installed, we can check the versions of Node.js and also npm. So, once this Node.js and npm are installed, then next we can move further to install a web3.js package. So, that part is simpler. You can, once you have npm installed, you can use it to install web3.js by simply running npm space install space web3, okay, and that will install web3.js library in your computer. So, we will be showing this for the Ubuntu operating system, but you can check the documentation page of web3.js to learn about the installation steps for other platforms also. So, this is the web page of web3.js. You can consult this to get instructions for installing in other platforms also, but we will be doing it for Ubuntu, and for that the first step is to install Node.js. Now, you can go to this Node.js website and there you will find the download option for Linux x64 architecture. So, you can just right click on this download button and click copy link location or copy link address, then you can just download it in any location. So, we will use this tool called wget, or you can download it through any download manager of your choice. So, we will do wget space and paste the address. So, at this point you can see that the Node.js compressed package is downloaded. So, the next step is to extract that. So, what you can do is you can copy the name of this compressed package and you can use the command tar space minus xvf space the name of this package to extract it. So, it would be extracting all the extracting this package in a subfolder called this node version 1.6 version 16.13, and next what you need to do is you need to set the path variable. So, in Linux, in Ubuntu, whatever executable you want to use, you need to set that in a path variable. So, we have downloaded it in our home folder, then nptel folder, and inside that this directory named node-v16.13.0-linux. So, we set the path according to that. So, the command is basically export path equal to, without any spaces you provide the path to the bin folder inside the extracted Node.js package, and then you put a colon and write $path. So, this will basically add the path of the Node.js package to your existing path. After this, if you want to see that if Node.js is installed properly or not, you can do that by using this command node space -- version, and I mean alongside Node.js npm is also installed by default. So, if you see npm version, it is showing the proper npm version which is installed. Now to install Web3, you can just simply do npm space install space Web3 and press enter. You can see that it is pulling Web3 and it is fetching it. Since in my system it is already installed, it basically finished instantly. To check if npm if Web3 is installed properly, you can just start node and try to import Web3. Okay. So if Web3 is installed properly, then the import statement would work. So the import statement is var space Web3 equal to require and then in quotes Web3. So if you do console log Web3 dot version, you will find out that it will print the proper version, and this will be your indicator that Web3 is installed properly in your system. So once Web3 is installed in your system, then you can use it to do all sorts of queries that we were also doing beforehand. So we were using the Go Ethereum client to query the balance of different accounts using some post requests for RPC over HTTP. Now instead of doing those post requests manually, you can use Web3, the libraries provided by Web3 to execute those requests more easily. Okay. So how can we use Web3? It is very simple. You have to import it first. So you can just do Web3 var Web3 equal to require Web3. So all these codes are basically JavaScript, since I mentioned we are using Node.js version of Web3. So in JavaScript, you can just declare a variable using var. So var space Web3 equal to require, then in quotes Web3. So this will be requiring Web3. Now the next step is very important. So how would your Web3 application connect to the Go Ethereum client which is running? So Web3 itself cannot connect to the Ethereum network directly, as we just saw in the previous diagram, that Web3 connects to the Go Ethereum client which is connected to the Ethereum network. So the Go Ethereum client can expose RPC over HTTP API, and we will be using that to connect Web3 to Geth. So from this slide, in the second line, you can see var Web3 equal to new Web3, and inside that we are passing this argument which is the URL of the RPC over HTTP endpoint. So it is http:// then localhost 8545. So 8545 basically is the port number where Go Ethereum client has opened the RPC endpoint. So after this Web3 is configured to connect to the Go Ethereum client using RPC over HTTP, we can use it to do different kind of queries. First we will see how we can query the balance of an account. So for that we can just do web3.eth.getBalance and then pass the address of the account that we want to know the balance for. Okay. And then since it is a promise, we can do then console.log. We will see how this code will work properly, and you will get the output like this. Notice here one thing, that the output that Web3 will provide is now in decimal and not in the hexadecimal format that you were getting while accessing the Go Ethereum client through RPC over HTTP directly. So Web3 provides you the tools to actually convert decimal to hexadecimal whenever required. By default, when you are querying the balance using eth.getBalance, then it is converting the balance from the hexadecimal and providing you the output directly in the decimal format. We will see how. Before you can use Web3 to connect to Geth, you need to first run the Go Ethereum client in the same HTTP RPC over HTTP enabled and unlocked account mode. Okay. So here you can see that we have run the Geth client, and then when it is running, we can then move to a new tab and start using this Web3 library to do some transactions. So if you move to a new tab, open up node, and then you can just type here var Web3 equal to require, then in quotes Web3. So if you press enter, then this will be importing web3 in this variable web3 with capital W. We will initialize another variable web3 with small w and do and assign new web3 and pass in the RPC over HTTP endpoint URL, which is 8545. Okay. So, once this is done, then our web3 knows how to connect to the Ethereum client. So, we can just do web3.eth.get balances to fetch the balance of an account and do dot then inside dot then console.log. So, what it will do is it will be fetching the balance of this particular account that we are pasting here. So, and then once this balance is fetched, we want it to log. So, you can see that we will be getting two outputs. One output we have already received and I am waiting for the other output. Yes, here we go, we have the second output also. So, the first output is basically the promise which is returned by web3.eth.get balance function. Okay. So, it returns a construct in JavaScript called promise. So, so it is basically not a synchronous execution. So, this statement will return immediately a promise, and when this query is successful, the get balance query is successful, it will execute something that we are passing by this dot then. So, we are passing console.log function inside dot then. So, when get balance query succeeds or fails, so whenever it has some result, it will be passing that result to console.log. Okay. So, when we press enter here, so it is immediately returning the promise. So, that you can see that we have this promise with inside that there are several things, and after some time you saw that the actual balance got printed, and this balance is again in decimal, not hexadecimal. Okay. And the unit is Wei, as we discussed in the previous lecture. So, it is this into 10 to the power minus 18 ethers. So, this execution was directly from the terminal, but while writing applications, of course, you won't be running everything from this terminal one line at a time. So, what you can do is you can actually execute this same code or write the same program in a separate file and then execute it like a program. So, for accessing the Ethereum network from a program, we can create a new file called querybalance.js. You can give any name and write our Node.js Web3 code there. Okay. So, we will be writing the same lines for Web3 going to require Web3, first importing Web3 and then connecting it to the proper RPC over HTTP endpoint, which is localhost, and then the port. So, here our port is 8545. So, whenever you are running the Go Ethereum client, it will print the port if you are specifying the HTTP option. So, after this you can simply query the balance. So, let me just write console log a line, so that we know that we have already connected to the proper Go Ethereum client. So, it will print balance of the account is this. So, we will be printing web3.eth.get balance and then dot then console log, and we will be passing the argument as of the blockchain account address that we want to use. So, we want to get the balance of this particular account. So, let me just paste it here, the account address for which I want to query. Okay. Now, our program is ready and you can just go ahead and save this in this file. So, our file name is querybalance.js, and to execute it you can simply do node space querybalance.js and press enter. So, notice the first line is printed immediately, but now we are basically waiting for the second the actual query to execute, and once it has executed, it will show you this print. So, here also you see that the balance is printed in the decimal format instead of hexadecimal. So, similar to this querying of balances from different accounts, you can also do transactions. Okay. Now, for executing transactions, the process is very similar to the one we were doing through curl and sending HTTP post request. Here also similarly, you would need to run the Go Ethereum client by unlocking one account, the account that you will be using to execute the transactions. So, sending a transaction means you would be signing the transaction and then sending it. So, there are two requirements, one is the account should be unlocked, and the second one is the particular account from which you are sending the transaction should have some ethers which are needed to pay the gas fees. Okay. So, in the last lecture we saw how you can get those ethers for test networks from the different faucets that are available. Now, here with Web3.js, we do not need to construct the post request manually, we can just use the Web3.js library to form a transaction. Okay. So, to define a transaction, we can actually define a JavaScript object like this. So, to prepare a transaction, we will be defining a variable called transaction, which will be an object, and this variable will have these particular members. So, we have a from, to and value, just like the JSON payload parameters that we were using to execute the transaction using the post request. So, the from will be the from address from the account where the transaction is being executed, and the account from where the ethers will be deducted that we want to send, and then this to address is the account where the ethers will be sent to, and finally, this value is the value that we want to send. Now, you need to set this value parameter in hexadecimal. Okay. We had to convert the value and put the hexadecimal manually with the post request method, but here with Web3.js it will provide you some utilities also. So, we will be using this utility called number to hex. Now, number to hex will take the input which is in decimal, and then it will convert it to hexadecimal format. Okay. So, this transaction variable. So, this transaction variable is defining the actual transaction that we are doing. So, mainly the parameters. Now, we will be using this web3.eth.send transaction. So, if you see the previous slide, we were using web3.eth.get balance. So, basically eth dot is followed by the name of the method that we want to be using. So, here the name is send transaction. Here we are using send transaction to transfer some ethers from one account to another, but you can also deploy smart contracts using the same transaction. So, once you execute this node transfer.js, so basically that this is the file name used here in this screenshot. So, once you execute the program, it will give you the output which will have the block number, the block hash where the transaction is mined. So, actually you notice here that this send transaction now is waiting for the result. So, it is waiting for the transaction to be mined, okay, and then once it is mined and included in some block, it is outputting the details of that block. Okay, so, we will go through this step by step. So, we are creating a new JS file called transfer.ether.js and opening up in a code editor. So, you can actually use any code editor that you want. This particular one is Visual Studio Code. So, the first few steps are exactly same as the steps we had in query balance. So, we need to require W3 Web3, and then we need to connect it to the proper RPC over HTTP endpoint. then we would be defining the transaction, which is basically the parameters for send transaction method. We would have a from address and then a to address. Let me paste those addresses here. And then we would also have a value, so for which we will be using web3 dot utils dot number to hex, and then we would be passing the number in decimal format. So 1 followed by 17 zeros or 0.1 ether. Then we would use this transaction variable to do our send transaction. So web3 dot eth dot send transaction, and then we would be passing the transaction variable as the argument, and then we will do dot then console dot log. So the output will come only after the send transaction is successful. So let us go back to the terminal and do node space transfer ether dot js, press enter. So it will take some time, a few seconds, depending on how well it is connected to the network. And then after some time, when the block is mined, so it will also take the mining time. So it will wait till the transaction is included in a block and the block is mined. So let us give it some time, and now you see that it has provided the output. So you can see that there is this block hash, block number, also the transaction hash. So you can copy this transaction hash and you can open up the Etherscan for the test network. Here we are using Goerli test network. So and then you can paste this transaction hash here, and here you can see that yes, it says that the transaction is successful, and it also has the block number which matches with the block number that is shown in the terminal. Okay, so in conclusion, we saw how we can use the Web3 JS SDK, which is a collection of libraries for building dApps. So you can add any logic in Node.js and use the Web3 JS libraries and utilities to interact with the Ethereum network and provide any kind of functionalities to the users. You can also build user interfaces using the other Node.js libraries for building GUIs and web UIs. So for building any interface for any kind of Ethereum applications, now you know all the layers and all the tools which are Go Ethereum client and then the Web3 JS APIs and the libraries. So the only missing link is the smart contract, which we will be discussing in the next lecture. Thank you.